Before we go into our study topic, I wanted to talk a little bit about the coolness of water and why water attracted our interest. First, it's a major solvent of the body. We use it to move many different kinds of solutes around in the blood, and even those things which don't dissolve in water are able to bind to their transport proteins because of the way water interacts with them. And it makes up a large part of our body composition, around 60% by weight in adults and a whopping 75% of newborns, which I thought was pretty crazy. It's used to regulate many of our homeostatic systems as well. An example we've been learning about recently is blood pressure, which when blood pressure rises, it triggers many different responses, but one of those is to release more water from the body. And this helps lower blood volume a bit, which will in turn alleviate some of that excess pressure. And water fulfills many other important functions as well, including temperature regulation, lubrication, and shock absorption. And the research so far has been able to link the water content in skin to some of its important functions. For example, it's been determined that the amount of skin hydration affects the barrier function, which is the ability of the skin to stop things from coming in and out. And it's also been found that dehydration causes dermatological issues like rough patches on the skin and a duller complexion than usual. So going forward, we're going to be referring to multiple different types of water intakes. So in order to understand the paper, it will have to be able to differentiate between them. Metabolic water comes from cellular respiration. And you've probably seen this equation before. But the important part for us is that if we input glucose and run it through cellular respiration, we get ATP, but we also get some CO2 and some water. And this makes up around 10% of our daily water needs, which isn't the biggest share, but it's definitely significant and worth keeping track of. And drinking water is the most easy to understand. It comes from literally just drinking straight water. But the one we're most interested in is dietary water, which we get from food and drinks other than water. So, while previous research has been able to link skin hydration with some of these measures of functionality, there's not a lot of evidence that addresses how water intake, and the one we're most interested in, dietary water, affects these functional metrics. And partially due to this lack of evidence, we don't have any official recommendations for water intake here in the US. So our study aims to kind of help address this gap in evidence, and we'll do this by measuring some of these biomechanics and seeing how they change when we ask the subjects to change their dietary water consumption.
Thank you, Elijah, for that introduction. Hello, my name is Joshua, and I'll be talking about the methods and design portion of this presentation. So in order to do that successfully, we'll need to go over sample population ethics, groups, measurement of skin functions, biometrics, and tools of measurement. Beginning with sample population ethics, we looked at a sample population of 49 females and all between the ages of 22 to 34. We did this so that we would avoid any variances that we might occur due to due to differences in gender or age. I also made sure to obtain written informed consent from all participants, and all ethical standards were met and approved by our institution's ethical commission, and we're all within this Helsinki Accords and any amendments following. For our groups, we had two groups based off their total water consumption. Total water consumption included all dietary, metabolistic based, and oral intake of water. Group one was accustomed to having less than 3.2 liters of water a day, and group two had more than 3.2 liters of total water consumption a day. And each participant in both groups was asked to supplement the normal diet with an additional 2 liters of water taken orally every day. For measuring biometrics, we analyzed 5 different functions of the skin. So first is the epidermal barrier function. And this is the function basically of the skin to limit passive water to loss, prevent microbial infection, and preventing chemical absorption from the environment. Epidermal hydration is the trapping and locking in of moisture. It's basically the ability of water of cells in the skin and epidermal cells to intake water from the environment and from intracellular fluid and keep it within the intracellular fluid compartment. We also looked at the extensibility, and extensibility is the ability of the skin to lengthen without breaking. And as a test, you can even take your skin and pinch it, and it kind of shows the ability to stretch and compress without experiencing deformation. After that, we looked at the elastic function, which is something most of us are familiar with, which is basically the ability of the skin to kind of bounce back after being depressed. And finally, we looked at the viscoelasticity, which is the resistance to shearing forces. So that would be like when you rub your skin or try to when you give an insulin and it's that ability to resist that stress. For measuring of the skin functions, we made sure that first all participants were acclimated to set room conditions, so no one would experience additional water loss from excessive sweating or due to a very low amount of moisture in the room. We measured 5 different locations, and that being the forehead, the zymoga, which are the cheekbones, the anterior parts of the arm, the palms, and the anterior thigh. For our tools of measurement, we use the food frequency questionnaire, which is something that allows us to evaluate what the participants ate. We also use Quetelet's formula and these other tools in order to measure skin ability and to conduct our statistical analysis. Now I'll turn the time over to Daniel for analysis.
Some of you might heard that 60% of our bodies is made of water. And this water is not only water that is coming from a bottle, but actually we have 3 different sources for water intake. So scientists made this food frequency questionnaire and asked the subjects to fill it out to better understand the percentages of water intake that they were drinking prior to the experiment. Here in the x-axis, we have 3 categories. DRW represents drink water, and this is the water that we can drink straight from bottles. MEW represents metabolic water. This water is water that is being produced inside our bodies from phospholipids, from proteins, from carbohydrates. And DIW represents dietary water. This is water that is contained in everything that we eat. So even this onion has some water molecules in it, and our bodies are going to be able to process them and use these molecules as needed. The y-axis represents the water intake percentage. DRW represented 32% of all water intake. MEW represented 10%, and 57% of water came from dietary water. Scientists needed to use this to separate people into 2 groups and start the experiment. Here in this graph, we have the transepidermal water loss changes in relation with the transepidermal barrier. The epidermis functions as a physical barrier to the external environment and works to prevent lost water from the skin. It moisturizes the skin, the outermost layer, and provides protection, helping us retain natural oils and nutrients. This x-axis has 5 categories for each individual body area. We have the forehead, the zygomatic, the hand, the forearm, and the leg. And then T0 represents the day prior to the first day when they started drinking water. T1 is day 15, which is halfway through the study. And then T2 is the final day, day 30th. In the y-axis, we have the percentages of water loss. So from this trend, we can suggest that there is a consistent improvement because we don't see a linear decrease, which means that we are not seeing any good results, saying that we're preventing water from going out of the skin. Here in this graph, we have the skin hydration changes in the surface of the skin. We are now comparing how hydration in the skin changed from day 0 to day 30, the last day. For group number 1, we can see that there is an increment for each of the 5 categories in the forehead, the zygomatic, the hand, forearm, and the leg. They all had a linear increment. Whereas in group number 2, which was the group with people who were drinking more water prior to the experiment, they didn't have a good result, or we don't see any increment or any good changes in the hand, in the forearm, or in the leg. So this table shows a consistent improvement of superficial and deep hydration in both groups, but changes are more observed in the group with lower initial water intake compared to the group number 2. This group number 1 had changes in all the anatomical surface of the skin. And these results create a suggestion that increments in dietary water intake would affect the skin the same way as a topical lotion would do.
Our findings suggest that there is indeed a link between a modest increase in water consumption and some positive impacts on our skin health. And those patients who weren't getting enough water to begin with are the most likely to see benefits from this. And I could see this having some applications in the clinical world as well, as a way to treat patients for dry skin when they can't tolerate the side effects from drugs as well. And some populations that might be able to use this are elderly and obese patients because they often have issues with dry skin. And that concludes our presentation.